Wow, look at this group. All right, good morning, guys. Welcome to College Algebra. My name is John Filesticker, Professor Filesticker, JP, Professor P, whatever you want to call me. And this is MAC 1105, Section 015, College Algebra. It's our first meeting of the semester. Hopefully that course name and code sounds familiar if you are here. Today we're going to do a few things. We do have to do that first day stuff, where we go through the syllabus and talk about the course policies and all of that. I'm going to introduce you to the system that we'll be using for online homework. It's not just going to be used for homework, it'll be used for the homework, the quizzes, and the tests. And then after we've done all that, we're going to talk about a little bit of mathematics. Before we get into that, I would just like to ask if you can, if it's possible, to turn on your camera. That would be really nice. I want to get to know you guys. And a big part of that is being able to see your faces and just have an idea of who you are. So if possible, please turn that on. If it's not possible, you've got roommates running around naked behind you or dogs are chewing on your leg, I understand. But if you can, please, thank you. Appreciate that. It's so nice to see you guys. Okay. Just a heads up, I suppose I should say this now since I am asking you to do that. The lectures here are being recorded. You guys probably all heard that, Zoom recording notification at the start. And so you can review the lectures. I will be posting those recordings to YouTube. So again, just be mindful of what's going on your camera. Okay. So I'm going to turn on a screen share here so you guys can follow what I'm doing as we go through this little introduction to the course. Whoop, sorry, I think my internet dropped there for a second. We're back. All right, so I'm going to turn on my screen share for a second just to kind of show you the way the course is going to run. My goodness, all right. So this program you see up here is called QCam. It's an interface for a document camera that I keep at my home here so I can do these classes. And this is our whiteboard or blackboard for the class. So as a general rule, anything you see me write here needs to go into your notes, right? Think of it that way. I'll do my best to not write anything here that you don't need. I'll try to be very efficient with what I write down. But anything that you see me putting over here should go into your notes, with the exception of what I'm about to do, which is a little title card. So this is MAC. I mean, obviously, if you want to put this in your notes, you can. MAC 1105, section 015, which is college algebra. And today's date is the 6th of January, 2022. Today, we're going to go over the syllabus. We'll do a little intro to My Open Math, which I'll abbreviate as MOM, Mom, My Open Math. And then we're going to start talking a little bit about real numbers, intervals, and maybe functions, if there's time. I think there will be time. Okay, so that's the plan. Every day I will do this at the start of class. I'll just make this little title card and I'll tell you what it is we're up to for the day. That way, when you go to view the YouTube videos later, this will be in the first few seconds and you can kind of flip through them and find whatever it is you're looking for. All right, so the first thing on our to-do list today is the syllabus. Since you, that's Calc 1, that's not you guys. Since you made it here, I'm assuming everybody has gotten into the Canvas page, which is very nice. My name again is John Filesticker. You can call me really whatever you want. I know it's a weird last name. If you're looking for the pronunciation, it's file sticker, like a sticker you put on a filing cabinet. Real quick, a little background about myself. I did my undergrad at UF. I went to a community college first. I actually dropped out of high school. I failed Algebra 1, the kind of high school equivalent class to this, 3 times. Once in 8th grade, once in 9th grade, and once in 10th grade. And then I dropped out. I had a sequence of terrible math teachers. I was a bad student and just deeply unmotivated. After working construction for a few years, I went back to community college. After going to community college, I transferred to UF, got my bachelor's degree in mathematics from UF back in 2011, 2012, somewhere around there. And then I got my master's degree from UF in 2015. I've been teaching at Santa Fe since 2017. I taught also at UCF for a while. I taught at UF for a couple of years. My personal specialty is analytic number theory, which means I like to do calculus to figure out questions about whole numbers. So the research that I've done there is in enumerative combinatorics with Ferrer's graphs, which is a fun thing. If you ever want to talk about that sort of stuff, I'd be more than happy to, but we're going to stay focused on the college algebra for now. What else is here? All of this other information is in the syllabus. Real quick, the office hours are 1 to 2 p.m. on Monday, Wednesday, and Friday. And if you want to join one of those office hours, you just click this link right here. Office hours on Tuesday and Thursday are 11 a.m. to 12 p.m. And if you want to join one of those, you just click this link right here. You'll be put into a waiting room after joining those Zoom meetings. And I'll do my best to bring you in very quickly or send you a message letting you know how long it will be until I can bring you in. Sometimes people do like to discuss private things, grade matters, stuff like that. So you might have to sit in the waiting room for just a second, but I promise I always get to everybody in the waiting rooms, even if we have to extend the office hour a little bit. Final exam. First thing I'm going to actually ask you guys to do today is to go ahead and get out your phone or whatever your primary calendar device is and put this final exam date and time in there, because you'll notice it's not our normal class meeting time. It's at a slightly weird time. It's at 10:30 a.m. and the date is April 26th, 2022. That's a Tuesday, so at least it is a class day for us. But please go ahead and put this in your phone or whatever calendar you use and put a few notifications in. I would recommend one like an hour before, one like 12 hours before, and one like 2 or 3 days before. That way, if you're getting lost in the sauce during finals week, stressed out, whatever, at least you'll be reminded and prompt yourself to study and get ready. So go ahead, take a second to put that stuff in your calendar. The next thing we're going to do is go over the syllabus. So I'm also going to ask you to do something there. Please go ahead and click this link in Canvas to download a copy of the syllabus and save it somewhere that you can find it. I recommend making a folder like on your desktop or wherever it is that you keep folders for random crap for this course, because I will ask you to save other things from time to time. First thing I need you to dump in there is a copy of the syllabus. Just click this link. You'll be prompted to open or save. Go to save. Hit OK. This is in Firefox. Chrome, it will look a little different. Safari, a little different, but you guys know how this stuff works. I have a folder for your class that I put under Spring 2022, MAC1105.015. Here's my copy. I'll save another copy just for fun. All right. So everybody has a copy of the syllabus saved and the final exam date and time in their calendar. The next thing we're going to do is go ahead and pop open a copy of the syllabus and talk through it. Oh, we don't want to do it in the browser. This is a little bit better here. All right. I'm going to turn my video feed off so we can pay attention to the words here. All right, so this is the syllabus for our course. I know every class does this. I know it's not fun. I'll try to make this quick and short. My name again, John Filesticker. I'm an assistant professor here at Santa Fe College. My office is A031D. That is in building A on the north side. So if you come in from the concourse, like the covered area, you turn left and go down the stairs. So downstairs on the north side of building A, there's an office unit there. My office is 031D. This email link, this is a mail to link. If you click this link in the syllabus, it will open up whatever your mail client is on your computer, tablet, phone, and send an email to me. But the best way to get a hold of me is using the Canvas messaging system. Those all forward automatically to my email, and they also, in the subject line, automatically include the course and section number. If you're going to email me directly using this link or by typing my email address in, please make sure you tell me you're in college algebra. I'm only doing one college algebra this semester, so you don't need to identify the section. But Canvas is probably the best way to communicate with me. This phone number rings in my office. Right now, I have that set up to forward to my cell phone, so you can get a hold of me by calling this number, but just be aware, I don't get caller ID. It just shows up as coming from my office, and I don't get voicemails until I go physically into the office to check. So calling me can work. If you dial this number, odds are I will answer, but if I'm unable to answer, leaving a message, it'll take me a while to get back to you, and without caller ID, I won't really know what's going on. I won't know who you are, what's up. So just be mindful of that. Canvas messages are the best way to get a hold of me. Class meetings, obviously Tuesday, Thursday, 9:30 to 10:45. Office hours, we already went over this. Monday, Wednesday, Friday, 1 to 2. Tuesday, Thursday, 11 to 12, and Zoom. If you need to meet with me outside of those times, for example, you cannot make this office hour on a week when you'd like to meet me, or if you need to meet with me in person, we can do that as well. Just send me an email, Canvas message, and we'll arrange a meeting outside of those hours. I reserve 5 hours a week to meet with students outside of these times. So don't feel like you're asking a favor or anything like that. I have time in the schedule specifically for appointments. So if you cannot come to these office hours, just let me know and I would be happy to arrange something with you. The final exam day and time, again, if you haven't put this in your calendar, please go ahead and do that now. Prerequisites, you all have those, otherwise you wouldn't be here. And if you took MAT 1033 at the college, odds are you're familiar with the first course material. So the first thing you're going to need for this class, and I'm actually very proud of this, is a MyOpenMath account. If you are familiar with college algebra at Santa Fe, usually we require you to pay for a Pearson account, right? A MyMathLab account. And for the first time, we are getting rid of that. So MyOpenMath is the new system we're using for college algebra. And it is beautiful because it is free. So you don't have to pay anything for an access code. Isn't that nice? In order to get into MyOpenMath, you can click this link or just go to myopenmath.com. If you have not registered, sorry, I'm currently logged in, but if you have not created an account, there will be a login page there where you can create a new account. After you've created your account and signed in, you will go to register for a course and use this course ID. This is how you tell MyOpenMath what class you want to register for. It's how you tell them, I want to be in Professor Filesticker's college algebra class. So just copy paste this course ID 133118, where they ask for that. The other thing they're going to ask you for is an enrollment key. This is kind of like a password. So you'll just copy paste this. This is the name of a famous mathematician, Euler, and you need to use the uppercase E. So go ahead and just copy paste those. The textbook we're using for this class is an open source textbook as well. The goal here is just to get the cost down to you guys. You don't have to pay for an expensive textbook, don't have to pay for an expensive access code. You can download a free PDF of the textbook by clicking this link. You can view the textbook online by clicking this link. I'll do that now. And you see here the first chapter. So we're going to talk about real numbers and basics of algebra. We're going to talk about exponents, scientific notation. Some of these things we're going to assume that you're familiar with from previous math classes. Some of them I will cover in a kind of en passant way, where we talk about them as we need them. Certainly, we will talk about factoring polynomials, rational expressions, all that good stuff. So the textbook and the online homework system are both free, and they're both linked here in the syllabus. Some of the other stuff you're going to need, a graphing calculator, like a TI-83, TI-84, those are okay. TI-Inspire, TI-89, anything capable of symbolic manipulation is not okay. So you need to make sure that you're using a TI-83, 84, something like that. I know that these are expensive new, they're somewhere around $100, and we're working to get the cost of the course down. So if you're having a hard time getting a graphing calculator or finding one that is affordable, let me know. I have 4 of them in my drawer here. I can lend some of them out. And we can also loan them through the college. The library has a system that allows you to check out calculators, but I believe it's for a limited time. So if you're having trouble getting your hands on an acceptable graphing calculator, again, the TI-Inspire 89, the fancy ones are not allowed. We need one of the basic ones. If you're having a hard time finding an affordable one, just let me know and I'll help you. The final thing that you're going to need for this class is a computer with an up-to-date web browser and a stable internet connection. The stable internet connection is actually quite serious. You saw for a second there, my internet connection dipped at the start of class. It's important that you have a backup system. So what I do is I have my cell phone that's capable of running a hotspot, and that's what I use for my backup. It's not terribly important for the lectures, right? If your internet goes out for a minute and you get booted, that's okay because I record the lectures and post them to YouTube. You can always watch the video and fill in your notes for the parts that you missed. But during a test, you really don't want to get booted out because then you have to come back through the authentication system. So I strongly encourage you to have a backup stable internet connection that you can rely on for the tests at least. The final thing you need is a smartphone that's capable of running Zoom. During class, I think it's wise to sign in from your laptop or whatever your main device is. But for the tests, we're going to use a proctoring system, a kind of dual-pronged proctoring system. We'll be using HonorLock on your computer, and we'll be using Zoom on your phone. And I'll explain the details of that when the tests get nearer. Course description, it's an algebra class. We're going to learn algebra, right? We're going to study real numbers and functions of real numbers and applications of those functions. Specifically, I'm going to work on solving equations, manipulating expressions, working with inequalities, playing with these types of functions. So linear functions, graphs are straight lines, quadratic functions, parabolas, polynomials of order higher than 2, like cubic polynomials, quartic polynomials, and so on. We'll talk about exponential functions quite a bit, and towards the end of the course, we will talk about logarithm functions. Throughout the course, we're going to be focused on solving real-life problems. That will be a nice mixture of real-life problems and just pure math problems. There's an official list of course objectives. You can click that link. I'm not going to go through these right now, but if you want a nice description of all the stuff we're going to do in the class, this is about as close as we can get to that. Tech policy, just be polite. If you're going to chat here in Zoom, that's great. I strongly encourage you to use the chat feature. If you want to ask questions, I will watch the chat closely. Just keep the chat focused, please. If you could, please avoid messaging your fellow classmates on other systems. I'm going to set up a Discord server for this class, and I encourage you guys to use the Discord to talk to each other. But during class, in order to avoid distracting one another, keep any chat you want to do here in Zoom. And keep it focused on the material we're discussing in class. Of course, during tests, you cannot use any phones, smart devices, communication tools, anything like that, right? That is absolutely forbidden. Attendance. So this class does have an attendance component, just a heads up. So the nice thing about Zoom is that it will automatically take attendance for me. I get a log of who's signed in and who is not. If you could, please make sure that the name you use in Zoom is the same as the name you have on your Santa Fe ID card, because that's the name that shows up in my roster. So in order for me to fill out attendance, for example, to get you your financial aid, I need to mark you as having attended class. In order to mark you as having attended, I need to be able to see from the Zoom logs that you were here and match that up with the name on the roster. So please make sure the name you use in Zoom is the same as the name you have on your Santa Fe ID card. The attendance policy is as follows. So 5% of the course grade is designated to participation, which is basically just coming from attendance. If you miss more than 5 lectures, then you'll start losing points there. So you get 5 freebies. After you've missed 5 lectures, each lecture you missed beyond that will be a half percentage of your grade, right? So if you miss 2 lectures, you'll lose 1% of your grade. If you miss 3 lectures, you'll lose 1.5% on your grade. But that's only after missing 5. So try not to miss any class, right? This is college. You guys paid to be here. Don't miss class. It's very important. But if you do miss more than 5, it will start affecting your grade. The max you can lose from missing classes is 5%. Makeup and late work, I'm pretty lenient about this stuff, right? So if you miss a homework assignment, or if you're unable to finish a homework assignment, I'm happy to extend it for you. Just let me know you need it extended. You can do that by sending me a Canvas message saying, hey, can you extend, homework 5, or can you extend quiz 3? And I'll go into my open math and change the due date for you. That's no big deal. The class also has exams, obviously. If you miss one of those, let me know as soon as you can. If you're going to miss it ahead of time because of something unavoidable, then we can reschedule you and have you take the test either before or after, whatever that thing is that's going on. If you miss an exam due to some unforeseen circumstance, like you got a flat tire or who knows, right? Life is life. Just let me know as soon as you can, and I will put you into a group for a makeup test. The catch here is that you got to let me know and schedule the makeup for no more than 1 week after the missed exam. There are also projects in this class, little kind of take-home worksheet things. If you make those, if you miss one of those, you're not here the day I hand out the project, or you're late turning it in, again, just let me know what's going on, and generally I'll help you out and let you get it done. The only thing in this class that cannot be made up are in-class activities. So we will do throughout the semester a total of 8 in-class activities. Those are little worksheets that we fill out while we're here in the lecture, and I can talk to you and you can talk to me. If you miss class on one of those days, you can't make those up. The discussion is an important part of that, and it's just one of the things that's about the structure of this class. In-class activities cannot be made up. So again, make sure you don't miss class, right? It's very, very important you come to class. The final thing here is that while I am happy to extend lots and lots of stuff and reschedule tests if you need them, the absolute cutoff for any assignments that you wish to turn in is the day of the final. So 11:59 on the day of the final, that's when I stop taking graded materials. Homework and quizzes. There's going to be a bunch of homework in this class, and there's going to be a bunch of quizzes in this class. So every day that we meet, I'm going to assign new homework. Every day that we meet, homework will be due. Some days you'll have 2 homeworks due, some days you'll have 1 homework due, but every class day you're going to have a homework set come due. The way it works, I open the homework sets on a given day, right, on a day of class, and that homework set will be due at the start of class on the next day. And I'll show you some examples, but just think of it like this. At the start of class every day, you have a homework set due, just like if you had to hand in the homework as you came in the room. There is a quiz associated with each homework, right? So each homework teaches you a technique, you practice it, and then there's a quiz associated with that homework, which is a much shorter assignment that has a fewer number of submission attempts. So for every homework, there is a quiz, and there will be about 2 of those per week. So about 2 homeworks and 2 quizzes per week. Some weeks there may be a little bit more, some weeks there may be a little bit less if we have a test or something like that, but that's the deal. All of the homeworks and quizzes are in MyOpenMath. So let me go back here and show you our course really quick. You do already have homework here. I was just playing around in one of them. So once you get into MyOpenMath, this is what the course will look like. I'll show you the student view. Okay, so you'll see some of these things have their due dates updated from last semester to due dates associated with this semester. So before our next class, right, our next class is on the 11th, next Tuesday, the following things are due. You need to complete the tutorial, which is just how to use MyOpenMath. You need to complete this algebra readiness assignment. And then you have your first homework, homework 1 on functions, finding domains and ranges, and quiz 1. All of those things are due at the start of our next class, right, on the 11th at 9:30 a.m. If you finish those in which to move on, you can start on homework 2. After homework 2 is quiz 2, and homework 3 after homework 3 is quiz 3. Those are due next Thursday. Right, so that's the vibe. Every class day at the start of class, you'll have some assignments due in MOM. There are other assignments that are visible here, right? You'll notice like homework 4, this has an old due date in it from last semester. You can get in here and practice with things, but because it's not open yet, you can't complete it for a score. So if you want to take a look at what's coming next, you can do that, but you cannot work these for a grade yet. And so there's plenty of stuff, and I'll make sure there's always plenty of stuff open. I'll always have the next homework assignment open and the one after that for people who want to work ahead. But every day that we have class, you'll have stuff due in MOM. And the time that it's due, be aware of this. I know some people use midnight on a given day of the week or something like that. The time that your homework is going to be due is right at the start of class. So you can work it right up to the moment we begin the next class. All right, projects and activities. So like I said, there's going to be 8 in-class activities. They're kind of sprinkled throughout the semester. I'll get to the course schedule in a minute. And then before each exam, there's going to be a little project, which is like a take-home worksheet thing that's meant to help you practice and prepare for the test. The in-class activities cannot be made up, and they're completed during the lectures here in Zoom. The projects I will post to Canvas for you to download, print, and complete. Those will be due usually on the day of the test. Speaking of tests, there are 3 midterm exams and 1 final exam. All of these are going to take place in MyOpenMath. The midterms are broken up into like units or blocks, they're called in MOM. And the final is a common final, meaning it's written by the department. It's the same for all college algebra classes. All of these will occur during normal class time, right? So you'll join a Zoom meeting just like normal. They'll be proctored by HonorLock and Zoom. The Zoom is going to be on your phone for the tests rather than on your computer or some other secondary device, a tablet or a second laptop, whatever you want to use. And then on your main device where you're actually taking the test, you'll have to run HonorLock. Just be aware, HonorLock requires that you use the Chrome browser. You need to keep your Chrome browser up to date. And you want to check and make sure that your HonorLock extension is also kept up to date. Again, the day of the final is Tuesday, April 26th, 10:30 a.m. Okay, here's the grade breakdown. So class participation, we talked about that, 5%. Just comes from attendance. Attend class, you'll be Gucci there. Online assignments, that's the homework and the quizzes. Those are worth 10%. So the homework is 5%, the quizzes are 5%. Activities and projects, that's 10% as well. All right, so the 8 activities and the 3 or 4 projects come to a total of 10%. And then the midterm exams collectively are worth 50%. The final exam is worth 25%. Let's see, I think this 12.5% each. This comes from when I had 4 exams. I'll have to change that. But midterm exams, 50%, final 25%. So the total grade in the class, 75% of it comes from proctored tests, right? The vast majority of the grade in this class comes from the exams. And you want to be aware of that, right? Don't take the exams lightly. We do not drop any exam scores, right? We do not do retakes on any exams. There's some differences between this class and intermediate algebra 1033. The one thing I will do Your lowest midterm will be replaced by the final if your final is better. So if you bomb one of the midterms, right, you get like a 30% on one of the midterms because you just were not ready for it. But then you learn that material and you do well on the final and you get a 70 on the final, then your 70 on the final will stay. And I'll also go back to that bad midterm and change that 30 to a 70. Okay, but that's the only sort of replacement or extra credit or drop test thing that we do. The grading scale is the standard one. 90 to 100 is an A. 80 to 90 is a B, 70 to 80 is a C, and then the top 3 points in each category get the plus designation. At the end of the semester, if you're within a point and a half of the next letter grade, I'll round you up, right? So an 89.5, if you're sitting at an 89.5 and you're like, oh, I'm so close to the A, I really want the A, don't worry, 89.5, you're gonna get the A. Important dates. These things you want to be aware of. Obviously, classes at the college started yesterday. The 7th is the last day you can add classes. That's tomorrow. The last day you can drop, get your money back and nothing on your transcript is the 11th. We're going to be closed for Dr. King's birthday on the 17th of this month. Spring break is the 2nd week of March. The last day to drop the class and get a W, I shouldn't say drop, the last day to withdraw from the class and get a W on your transcript is 23rd of March. The last day of class itself is April 22nd, and the final exam is again on the 26th. You can see your final grade for the course posted in East Santa Fe by May 3rd. The next page here is all kind of boilerplate syllabus stuff. The GELO, General Education Learning Outcome, is a statistic that the state and college need us to track to see how well I am doing as a professor. This has no bearing on your grade, and there will just be a few questions on the final. If you get those questions right, or you get a certain score on those questions, you'll get the GELO credit. If not, you won't. It doesn't, again, have any bearing on your grade or show up on your transcript at all. Academic integrity, you can read these things as the college officials' academic integrity rules. One of those things you definitely want to know. Basically, don't cheat, right? We'll talk more about that down here. The ADA, Americans with Disabilities Act, if you have a learning disability or any other sort of disability, please talk to our DRC on campus. They're amazing and helpful people. They are very, very kind, and I want to make sure that you get whatever sort of accommodations you're entitled to. Even if you're not registered with the DRC, but you think you should be or could be, you suspect that there's something going on that makes the system a little bit unfair to you, just reach out to me. Sometimes the DRC takes a while to do paperwork. They often require letters from psychiatrists or whatever. If you're in the middle of that process or beginning that process, but you don't yet have an official accommodation from the DRC, just talk to me. I'll be happy to give you the accommodations. I would much rather do that than have you suffer unfairly. Accessibility. This is a math class, so it is a little bit challenging to get all of the materials in a form that will work with a screen reader, but I do type all of our official materials up in the LaTeX markup language, which works well with screen readers and all of those other accessibility hardware. The videos that I'll be posting to YouTube are closed captioned automatically by the YouTube AI. They do a pretty good job. There isn't much punctuation in the subtitles, but they actually get the words correct most of the time. If you're having any sort of trouble with accessibility, being able to read, hear, or understand anything that's going on in the course, please just let me know and we will get you the materials and equipment you need to make things work. Discrimination, harassment, just don't be an asshole. Student rights and responsibilities, again, this is stuff you should know, just because that's your rights, right? What are you entitled to from the college, and your responsibilities? What does the college expect from you? I checked yesterday, I think this link is broken. So if we want to see the student rights and responsibilities, post the link in chat here. I have not yet updated it in the syllabus. There it is. All right, so you can check this stuff out. There's a lot of good information, good material in there. There's one thing I wanted to mention in here. Okay, so complaints. This is something that my wife and I had to go through. She had a professor, unfortunately, in our own department who was very inappropriate, and we had to go through the formal complaint process with that. I want to invite you to read this, be aware of it, and if you feel like anybody on campus is ever treating you unfairly or inappropriately, please use this. It's important that we hold the faculty and staff here to high standards, just like you students. You guys are held to high standards. Computer access, if you're having trouble getting a computer that does what you need it to do for the class, go to the laptop loan program. They've got a shitload of pretty nice laptops that they will give you for a whole semester for free. You just got to tell them you need it. Counseling services. These guys are amazing. I cannot tell you how many of my students have been helped out deeply by the counseling services. Again, people in my own family have been helped out by the counseling services. People, wonderful folks. If you're feeling sad, upset, cornered, trapped, whatever, I know we all go through it. It's totally normal. These are professionals that are there to help you with that stuff. And I promise you, they really do help. So don't be shy about reaching out to them if you are feeling in any way overwhelmed or just trapped, right? All this other stuff, I'm not going to read through all of this. There's way too much here, but you should be aware of your rights and responsibilities as a student at college. All right, here's the last thing in this stuff, and I'm sorry I'm preaching. I know that over the last 2 years, it's been easier to cheat, right? I don't judge you guys for it, and I'm not saying anybody here has done it, but I know that it has been easier to cheat. I also want to let you know that I've got one too, right? I have Photomath, I have Mathway, I have Symbolab, I have Wolfram, I have Desmos. I've got all the apps here that you have, right? This is my job. And I scan all of my materials through those apps. I run all the stuff that I give you guys through all of the classic cheating apps. I know what those apps output, and I know what a genuine organic solution to a problem looks like. So please just be aware, right? Just be aware that copying stuff from Mathway will get you caught. Copying stuff from Photomath, Symbolab, wherever, Bartleby, Chegg will get you caught. I've caught people with all of those things. Please don't cheat. I know that the standards over the last couple of years have not been as sharp as they should be. I've talked to many students who've told their professors, hey, so-and-so is cheating and it's driving me nuts and it's not fair, and the professors just don't care. I'm not that guy. Last semester in my pre-calculus class, I caught 6 people cheating on the final, and I turned them all in. I caught 4 people cheating on the 3rd midterm, turned them all in. My record on the test is 9 people. I caught 9 people in fall 2021 cheating on the final in my Calc 2 class, turned them all in. My rule for this, the first time I catch you cheating, I'll give you a 0 on that assignment, and I'll send a little notice to Dan Rodkin's office, but I won't send a formal complaint. The second time I catch you cheating, I'll give you a ZF in the class, right? That's an F overall in the class, but not just a regular F, a ZF, which means an F for academic misconduct. And that is like a nasty black mark on your transcript that you really, really don't want. Obviously, you don't want a 0 on any assignments either, but I'm just letting you know ahead of time, right? That I know what the shit looks like, right? I catch people with it all the time. For whatever reason, it's assumed that we won't notice those things. And I think with many professors, maybe older professors or whatever, that's the case. But that's not the case with me, right? I do catch folks when they cheat. It makes me feel bad. And I don't like doing it, but I have to. It's very important that we preserve the value of your degrees. Your degrees aren't worth anything if people know that students cheat through the classes here. So please don't cheat, right? Please don't cheat. I promise you I'll catch you if you do. Please don't do it. Look at my Rate My Professor. It's got several students in there going, don't cheat in this class, he'll catch you. I haven't checked in a few months, but I bet there's a few more from the 6 that I caught in that last test. So please don't do it. Please don't do it. The other side of that coin, right? I will catch you if you cheat. And if I catch you, I will be ruthless about it. The other side of that coin is if you're feeling trapped, if a test is coming up and your mind is shifting from like studying to thinking about where you can hide a cheat sheet or where you can keep a second device in your lap or something like that. As soon as you notice your brain starting to do that, stop, send me an email or a Canvas message. Let me know that you're not quite ready for this test, and I will work with you, right? I can move the test up to a week for you. I'll always do a makeup session for a test for people who are sick or have other sort of problems. If you're in that position where you're like just not ready for the test, let me know and I'll move you into that makeup group and give you some extra time to study. If you need it, we can have extra one-on-one office hours. I can arrange one-on-one tutoring for you. There's a lot of stuff that I can do to help you get ready for the test, including giving you more time. And I've got no problem doing that. But if you cheat, I'll catch you. When I catch you, I won't be nice about it. So please, please don't cheat, right? I'm willing to work with you. Communicate with me. Keep those channels of communication open. I promise you can do this stuff. You really can. It feels hard at a lot of the steps, but once you put in the time, it will feel easy. That feeling of like going from I don't know how to do this to I know how to do this is a great feeling, and I want you guys to have that. I want to help you get there. Please don't cheat. Let's do it the right way. Okay, that's enough of me preaching. Here's the course calendar. These dates are approximate, they may change, but this is roughly what we're going to cover and when we're going to cover it. So this week, we're going to talk about real numbers, functions, and the concept of domain and range. We're going to do our first activity. Since we only have one class this week, that first activity is going to be bumped to next week. Week 2, we're going to talk about graphs of functions. We're going to talk about linear functions, right? Functions like whose graph is a straight line. We're going to talk about slope and rates of change. And we're also going to talk about linear regression. So we've got a lot of stuff going on next week. The week after that, we're going to talk about absolute value. We're going to introduce quadratic functions and this concept of the discriminant. You can see there's going to be a lot of topics here. I'm not going to read through all of them, but each week I'll list the important things that are going on. Of course, there will be a homework associated with each class. So the first test is going to be in the 4th week, the last week of January. The second test is going to be in the 2nd week of February. And the third test, the last midterm, is going to be in the 2nd week of April. And then the final exam, again, is April 26th. All right. Are there any questions about the syllabus, the structure of the course, kind of what I'm expecting of you, or where your grades are going to come from, anything like that?
I have a quick question.
Yeah, Samantha, what's up?
When we get a test, do you do a review, or are the quizzes and everything still open?
So all of the material in My Open Math will stay open for you to review. So you can use those as a review. The other thing that I do, you notice before each test, there's a project. So project 1 comes just before exam 1, project 2 comes just before exam 2, and project 3, oh, I said project 4, project 3 comes just before exam 3. Those are intended to serve as a bit of a review. If there is time in that week during lecture, then I'll do a formal review where you guys can bring questions and we can just spend class time doing that. But it's likely going to be the case that there's not a lot of extra time in class. So we probably won't have a full class review session before each test. But the days where we're talking about the projects, we can treat as a review. And then if you want extra review, you can come by my office hours and we can do that there. For the final, usually college algebra, for the final, I do put together a big review.
Okay, thank you.
So that's just the other materials. Okay, one last thing before we get into the math, the grade book. So there are 2 grade books, and I don't know if you guys can see. I think, yeah, you probably cannot see the grade book in Canvas. That's good because the grade book we're going to use for the class is in My Open Math. So if you want to track your grade and see how you're doing in the class, just go to the grade book in My Open Math. Obviously, there's not going to be anything there yet, but in the future, that is where you'll be able to see your grades. All the weights are put in there. Everything is put in there, so you can calculate your grade at any time. Okay, so that's the course, right? You've got several assignments open in My Open Math right now that are due on Tuesday of next week, right? They're due at the start of class next week. Any other questions for me about the syllabus or My Open Math stuff? You guys know how to use reacts in Zoom. If you look on that bar on the bottom, there's a reaction option. Could you give me just a thumbs up if you have registered for our class in My Open Math? Okay, very nice. Very nice. If you do have any trouble registering for the class in My Open Math, please get a hold of me. Again, Canvas message is the best way. But please let me know so we can get you guys in there and get you working. Because again, homework and stuff is going to be due starting next class at the start of class. The first few assignments in there, there's an introduction to My Open Math tutorial, how to use it, right? This is just about how to enter answers in My Open Math, how to type things. If you did 1033 here at Santa Fe, you're probably familiar with all of this. It will go very fast. The next assignment after that is an algebra readiness assignment. This is just kind of a review of the basics that you should have learned either in high school or previous classes: multiplying, adding, subtracting numbers, basic works with units, order of operations, all that good stuff. After that is going to be the actual homework. So I'm going to start now on the material for homework 1. We'll talk a little bit about numbers. So remember, everything that I write on the document camera here, this is the stuff that should go into your notes. Okay. So if I want to refer to the set of real numbers, all of them at once, I will use this symbol on the left here, or on the right here, which is a blackboard bold R. It's an R with a capital R with an extra leg. The real numbers can be thought of as all possible distances both positive and negative. Right, so if I want to talk about how far this pen is from this pen, right, the answer is always a real number. Might be here, 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 but all possible distances. You can think of that as one way to describe the real numbers. They form what's called a complete ordered field. These words don't mean a whole lot to us, but a field is an algebraic structure where you can add, subtract, multiply, and divide, right? And get something that lives within that algebraic structure. So if you think about the set of whole numbers, for example, the whole numbers do not form a field. You can add two whole numbers and you always get another whole number. You can multiply two whole numbers and always get another whole number. But if you start dividing whole numbers, you might not get a whole number. So a field is a place where you can do all four of those operations, and the answer is always something from that set. Ordered, this means if you have any two real numbers that are different from each other, right, non-equal real numbers, one is always bigger than the other. In other words, this says you can arrange them on a line. And then complete, this is the big one. This means that there's no gaps, and that's kind of a weird thing. So if you take your real line, here it is, here's the number line, right? This is all the real numbers. Maybe 0 is here, maybe 1 is here. Negative square root of 2 is over here. Maybe, I don't know, 1 over pi is here. Stuff like that. No matter how tight you zoom in on any point of this number line, on any chunk of this number line, like if I zoom into this region from 0 to 1 over pi, you'll never find a gap. That's actually very special. If you think about all the other number systems out there, that's not true. The whole numbers, of course, there's gaps between 0 and 1. Even if you look at the set of all fractions, there's gaps when you zoom in, right? Because like pi or 1 over pi, that's not a fraction. Those are irrational numbers. So this fact that the real numbers can be arranged on a line and there are no gaps anywhere in that line, no matter how tight you zoom in, is a very big deal. And a neat fact about real numbers that I want to get out there right away is that between any two real numbers, there are infinitely many other real numbers. So you can think of each point on this line as representing one real number. So again, if I zoom in here and I look at this, it's called an interval between 0 and 1 over pi, there's infinitely many points in there, right? This line is solid. No matter how tight you zoom in, you'll never find a gap. So between even these two very close real numbers, there's infinitely many other real numbers. For example, 1/10 would be like right here, right? 1/7 would be like right here. Lots and lots of real numbers. Okay. The next thing we need to talk about is interval notation. And I'm going to be pretty brief about this because it's something you're supposed to be familiar with. But I want to make sure we're all on the same page. There are two types of intervals, or two kind of topologies that we can talk about. Those are open intervals and a closed interval. I don't know if you guys have seen this. This is kind of a joke in bad taste, but I'd like to share it with you really quickly. I'm not going to play it right now, but open and closed are terms in mathematics that have very specific meanings. It's a part of the field of mathematics called topology. And there's this pretty hilarious video taken from a famous movie in the early 2000s called Hitler Learns Topology. Pretty funny stuff. Open and closed are not necessarily opposites of each other. What they mean are this. So the open interval, let me say this also, sorry, let A be less than B be real numbers. Then the open interval from A to B is all numbers X satisfying a certain inequality. So the open interval from A to B is all the real numbers strictly between A and B. That is, all the numbers which are strictly bigger than A and strictly smaller than B. So the way we would write that as an inequality is all real numbers X satisfying A is less than X. So the numbers in the interval X are bigger than A. And also X is less than B, right? All the numbers in the interval are less than B. And this is denoted with an open parentheses, A comma B. All right, that's what an open interval is. A closed interval is similar. You just use a weak inequality instead of a strict inequality. So the closed interval from A to B is all numbers X satisfying A is less than or equal to X is less than or equal to B. And this is denoted using these closed brackets, A comma B. So the big difference between the open interval and the closed interval is that the closed interval contains its endpoints, right? The closed interval, because it has these less than or equal to, contains both of the numbers A and B. Whereas the open interval has all the same stuff, except it doesn't contain the endpoints A and B. Okay, hopefully this is something you've seen before. Interval notation is pretty common in algebra classes, but I just want to make sure we're on the same page notation-wise. Are there any questions about what these intervals are? Or the notation we use to describe them, or the inequalities used to define them? Okay. Quick example. And I'm going to ask for some participation here. I want you guys to tell me or to list 3 real numbers which are in the interval open interval 0 to 2. All right, so you can shout them out. To speak here, by the way, you hold down the spacebar button. It's like a walkie-talkie. So if you want to talk, hold down the spacebar. Could anybody, or you could type into chat, just tell me 3 real numbers that exist in this interval.
Is it 1?
Certainly 1 is in there. Yep. Yep, strictly between 0 and 2. 1 is a number that is between 0 and 2. What other numbers are between 0 and 2? Just give me some examples. There's lots and lots of them.
1.5.
Very good. 1.5 or 1.5, which we could also call 3/2. Okay. Can somebody give me another example? .5, yeah, 0.5 or 1/2. I'll tell you now, I really appreciate the interactivity. Mixed numbers and decimals will show up from time to time in this class, but we want to focus on getting comfy with fractions. So you'll see every time that I'm working with something like this or something like this, I'll do my best to give you the fraction representation of it as well. And working with, reducing, doing algebra with fractions is going to be a big part of stuff in this class. Some other examples here. 1/3 is in this set, right? If you want some irrational numbers in this set, 1 over the square root of 2 would be in this set. Lots and lots and lots of things. Okay. We can combine open and closed intervals in several ways. So first, it's possible. So I'll preface examples, by the way, with the letters EG. It stands for examples gratis. It's gratis. It's a Latin abbreviation, which just means for example. One of the ways you can do this is by looking at the left open, right closed interval. So kind of taking the open parentheses on the left and the closed bracket on the right. This is all numbers x satisfying what you would think. So the parentheses means strictly bigger than, and the bracket means less than or equal to, right? So this would be all the numbers that are strictly bigger than A and less than or equal to B. So it's all the stuff that is bigger than A up to and including B. That would be A is less than X is less than or equal to B. You can do this the other way, where you close on the left and open on the right, which is all numbers X satisfying A is less than or equal to X is strictly less than B. And then we can also use the union notation. Set operations, union, and intersection. So the union of two sets, set operations, union, intersection can be used to combine sets. So for example, if A is a set of some stuff, right? Just think of this as a box containing some things, probably numbers. A union B, where A and B are both sets, this is all the stuff in the set A together with all the stuff in the set B. So basically you're taking those two boxes and you're throwing all the stuff from both of those boxes into one box. That's what the union operation does. And you can perform that operation on intervals. You can union two intervals together. And that means you're just talking about all of the things from that first interval together with all of the things in that second interval. The other operation, A intersect B, this does kind of the opposite in a sense. It takes only the overlap between A and B. So this is all the stuff which is in, I should say, which is common to both A and B. And if you're familiar with Venn diagrams, there's a picture that goes along with each of these. The picture for the union in terms of Venn diagrams, if here's my set A, and here's my set B, I will shade the union here, bluish greenish color. All that stuff put together is A union B. And in terms of Venn diagrams, the intersection, here's my set A, and here's my set B. The intersection is just the overlap, just what is common to both. We'll use the union symbol more than the intersection symbol, but I'll use the word intersection from time to time. And there may be some occasions where we need to actually intersect two sets. Okay. Any questions about interval notation or union and intersection? Let's try one quick problem here. So can I take the interval, the left closed right open interval from -1 to 3, and the open interval 0 to 5, and compute their union? Anybody have an idea as to how we could do this?
Would we do like the lowest number with the highest number with the union, maybe?
That's going to turn out to be the case here, yeah. So what I would do if this doesn't jump out at you right away is sketch this set on the number line by sketching both of those intervals and then following the rule up here that says we're going to take all the stuff in the first together with all the stuff in the second. So the interval from -1 to 3, I'm going to put -1 over here, and I'll put 3 over here. That left closed, right open interval is all of this stuff. Right, and again, the bracket and parentheses mean what they do in the interval notation. So this means -1 is included in this set, and everything up to, but not including 3, is in the set, right? So it's all the numbers that are strictly smaller than 3 and bigger than or equal to -1. That's this first set. Now 0 is over here, right? 0 is definitely between -1 and 3, so I'll put 0 there. And 5 is over here. So the interval from 0 to 5, that is this stuff. So now what I'm doing is I'm asking, what is all this stuff put together? If I throw all this stuff, the first interval from -1 to 3, and the second interval from 0 to 5, and I throw it into one basket, what is that interval? And I think somebody said it a second ago. What is the left endpoint going to be?
-1.
Very good. So I'll say this union of two intervals is a new interval whose left endpoint is -1. What is the right endpoint of this union going to be? 5, very good, thank you. Okay, is -1 included or not?
Yes.
Mhm. So do I use a parentheses or a bracket here?
Bracket.
Bracket, very good, thank you, Lexus. So put a bracket there, and then what about 5? Is he included or no?
No.
No, because it keeps going.
Very good. Yeah, if we look at the number line here, we see everything up to but not including 5 is a part of this set. So we put a parentheses here. Any questions about how we wrote this interval union of intervals as a single interval here? Okay, and a little pro tip. I saw someone taking a picture there, and that's fine. If you want to, look on your keyboard. There should be a button that says print screen or PRNT-SCR, something like that. If you hit that button, it'll take a screenshot, and then you can paste that into Paint. For example, here, watch, I'll hit my button. It's function delete, and then I'll pull up Paint, and then it'll automatically paste into Paint. It copies that screenshot. So it's a nice way to save things if you want to save a particular page of notes. Try that out. Try taking screenshots if you need to.
I just had a quick question. When you said 5 wasn't included, you mean like it didn't include a closed bracket, but include an open bracket?
Exactly. Yeah. So 5 is the endpoint here, but because when we look at this set, the number 5 itself is not an element of this set. So the open parentheses here indicates that everything up to 5 is in the set, but 5 itself is not in the set. So if I wanted to list some numbers that are in this set, certainly -1 is in this set. -1/2 is in this set. 0, 1, 2, 3, and 4 are all in this set. 4.9 is in this set. 4.99 is in this set, but 5 itself is not in this set. There is an alternate
Can you give an
notation.
example where like it would be the opposite?
Yeah. So really quick, before we move on, the alternate notation for this, some people like using filled in dots. So my first interval, the interval from 0 to 3, I could express like this. Filled in on the left, open on the right, which means that -1 is included, but 3 is not. And then the second set would be an open circle at 0 and an open circle at 5, and then everything in between shaded. So if we look here and we want to answer what is this new interval, you can see everything shaded between -1 and 5 is in the set. -1 is filled in, so he's in the set, but 5 over here is open. He never got shaded, right? The 0 and the 3 both got shaded when I filled in that second interval. But the 5 is still has an open unfilled circle here, which means 5 would not be an element of the set. We can do one more example where things go a little bit differently. And then we are going to start talking about functions. This time, let's compute an intersection. So write the intersection. Let's do 0 to 7 closed, intersected with about the open interval from 1 to 4 as a single interval. So again, my suggestion for this sort of thing, anytime you're having to think about combinations of intervals, would be to sketch them on the line. Zero is the smallest number in any of these things, so I'll put 0 over here on the left. 7 is the largest number in any of these things, so I'll put 7 over here on the right. And if I want to shade that first interval, if I want to sketch that first interval, that would look like this. If you like the other notation, you would put a filled in dot here and a filled in dot here. So that's the closed interval from 0 to 7. That includes 0, 1, 2, 3, 4, 5, 6, and 7, as well as all the decimals in between. The open interval from 1 to 4, here's 1, here's 4. The open interval from 1 to 4 would look like this. And then for the intersection, remember this operator here just takes the stuff that is common to both sets, takes just the overlap. So what got shaded twice here? What is this intersection?
1 to 4.
Very good, very good. It's just the interval from 1 to 4. So 0, 7 bracket intersected with 1, 4, both in parentheses. This new interval that I get by intersecting those two is just the stuff that got shaded twice, just the overlap. And that's going to have left endpoint 1 and right endpoint 4. Now, do I include the 1 with a bracket or do I exclude it with a parentheses? Is 1 in both of those intervals?
That would have a bracket, right?
So 1 is certainly an element of the first interval, right? 1 is in the closed interval from 0 to 7. The 1 got shaded with the first guy. Is 1 an element of the second set? No, this is just everything strictly between 1 and 4, right? Anybody? Okay, I love you. Be safe. Sorry, my wife had to leave. So 1 is an element of the first set, but it's not an element of the second set. So is it an element of the intersection? Is it a part of the overlap? Yeah, is that Chady or Chadi? In chat got it there.
It's chatty.
Chatty, okay, thank you. Yeah, the answer to that question is no, right? 1 is not an element of this intersection because while it is an element of the first set, it's not an element of the second set. And the intersection is just the overlap between the two. It's the stuff that is common to both. And the same is true of 4, right? So this would end up being just the open interval from 1 to 4. We'll have more opportunity to practice this. And like I said earlier, the intersection operator is not as important for our class as the union operator. But we can play around more with this in office hours if you like. For now, I do want to get to the material and functions because I want you guys to be able to begin that first homework set, which is due on Tuesday. So let's do that, okay? So here's our first kind of real unit, non-review, functions, domain, and range. And I think this is probably something that most of us have seen before. But I'm going to give you a definition, just in case. A function, and I'll give it a name here, f. It's usually the name we use for function, sometimes other letters. A function f is a relation or rule for pairing objects, right? So I have two sets, and what a function does is it pairs an object, so pairing objects, let me make this more explicit, from one set with objects from another set. All right, and we're not quite done with this definition, so leave some space. A function f is a relation or rule for pairing objects from one set with objects from another set, such that each object from the first set which is called the domain, is paired with exactly one object from the second set. Which is called the range or codomain. We'll call it range here. All right, this is a pretty formal definition. It doesn't give us a really good feel, but it is what you should rely on when somebody asks you, is this relation a function or not? So a function is a rule that pairs objects from one set called a domain with objects from a second set called a range. You can think of it as a mapping. If I call that first set A, and I call that second set B, then we can imagine a function. Maybe there's just three things in that first set. Call them little a, little b, little c. All right, and maybe there's three things in that second set. Oh, actually, let's make it two things in that second set. Call them let's call them y and z. Then I could have a function f that pairs a with y, and one way to denote that is by drawing an arrow from a to y. And it might pair both b and c with the object z. So these arrows, which are the rule for pairing, is the function, right? The two big blobs here are the sets a and b. A just contains the objects a, b, and c. B just contains the objects y and z. And the function itself, f, is the arrows that pair the input a with the output y, the input b with the output z, and the input c with the output z. I want you to think carefully whether this satisfies the definition above or not, because there's something a little bit weird about this, right? We need each object from the first set to be paired with exactly one object from the second set. Is that satisfied by this diagram or not?
No.
So I'm glad that you said that, because that's definitely what I'm trying to elicit here. It's a slightly sneaky thing. So how would you contradict this statement? Each object from the first set is paired with exactly one object from the second set. That would fail if there was one object in the first set that got paired with two or more objects in the second set. So I want you to think again, does this or does this not satisfy that definition? Is there any object in the first set that gets paired with more than one object in the second set? Yeah, there is not any object in the first set that gets paired with more than one object in the second set. This does describe a function. This describes this diagram, describes the function f, which pairs a with y, pairs b with z, and pairs c with z. So each object, a, b, and c, in the first set gets paired with one and only one object in the second set. It's okay that two objects from the first set go to the same object in the second set. That's not a problem. That's okay. What we could not do is send a to both y and z. That would violate the definition, because then you'd have one object in the first set being paired to two different objects in the second set. There's a notation for each of these things. I'm going to show it to you now. You've seen it before, I'm sure. This is usually written as f of a equals y. Right? When I say that the object little a gets mapped to or paired with the object y, the way we describe that is by writing f parentheses a equals y. And the words for this is f of a equals y. You can think of f as an animal that has these parentheses as its mouth. It eats a, and when f eats a, it poops out y. Right? I know this is a little bit gross, but what you excrete is a function of what you consume, right? There is a I know this is gross, right? But there's a mapping between what you consume and what you excrete, right? Everything that comes in sends something out. And nothing comes out unless something came in. That's a function, right? So the F here is a little animal. The parentheses are its mouth, and the thing that comes out when you feed that animal A is Y. So this is the notation for that. I know it looks kind of like multiplication. The first thing I really need you to get through with this notation is that this is not multiplication. This is not F times A. This is the animal or function F eating the input A and pooping out the output Y. The other two things here can be written in that notation as well. F of B is equal to Z. So when you feed the function F the input B, it poops out Z. And when you feed the function F the input C, it also poops out Z. All right, this on the right here is called function notation. The A's, B's, and C's are inputs. The Y's and Z's are outputs. And it is okay for outputs to repeat. It's not okay for inputs to repeat. That's the idea. There are several ways to describe functions. One of them is this mapping diagram, right? That's what this is called, is a mapping diagram. You won't run into these a lot, but they are kind of the easiest way to conceptualize a function when you're first meeting them. We can also describe this with a table. And sometimes this is called the tabular description of the function. The inputs up here would be A, B, and C. And the outputs over here, A gets mapped to Y, B gets mapped to Z, and C gets mapped to Z. And if I label that first row as inputs and the second row as outputs, then you can check from the table whether this describes a function or not. So is there any one input that goes to two different outputs? That's what we're checking when we ask, is this a function? Well, the input A goes to the output Y, right? That's what this says. The input B goes to the output Z, that's what this says. And the input C goes to the output Z, that's what this says. So is there any one input that goes to two different outputs? No. Right? If I had A going to Y and A going to Z, that would be the input A going to two different outputs, and that would be bad. Let me show you an example of something that's not a function. This time I'll use some numbers. Maybe I'll hold here just for a second. And let me include one more little bit. So the set of all inputs and these are usually X values, although sometimes we'll use other variables, is called the domain. The set of all outputs usually Y values is called the range. So I'll hold here just for a second. Anybody needs a minute to write? Okay, it looks like most of us are done. Again, if you leave your cameras on, I know it feels a little bit invasive, but that helps me get a feel for when we're ready to move on. So if you're in a position where you can do that, I'll ask that you do that. Okay, moving on. I'm going to describe a relation here using a table, and I want you to tell me whether it is or is not a function. This time, instead of using symbols, I'm just going to use numbers. For the set of all inputs, I'll use x. So, which relation are functions? I'll give you a few of them. Okay, here are three relations described through tables. I'd like to go through them one at a time, starting with A, and say whether they are or are not functions, whether the variable y is represented as a function of x or not. And then, if the thing is a function, we're going to state the domain and state the range. Let's start with A. Is A a function? What should we be checking? Before you answer, really quick, what should we be checking to see whether A is or is not a function?
We're checking to see that each input has the same output or exactly one output.
Very good. Yeah, we want to make sure that each input, each x value, gets sent to one and only one output or y value. In other words, what we should be looking out for is what Chetty said, is there any given x that has two outputs or more? So here the input 0 goes to the output 0. Does the input 0 get sent anywhere else? No. And the same is true of 1. The input 1 goes to the output -2, but nowhere else does 1 get sent to some other output. The input 3 gets sent to the output 7. So 3, is he sent anywhere else? Nope, I don't see 3 listed anywhere else. Does the input 5 get mapped anywhere besides pi? Nope, I don't see 5 getting paired with anywhere else. So this is a function. Now the domain and range here are a little tricky to describe. Remember, those intervals, they have infinitely many numbers in them. So neither the domain nor the range here could possibly be an interval. There's only 4 things in the domain. There's only 4 things in the range. So the domain, yeah, if you gotta go, you gotta go. This class is supposed to get out at 10:45. Yeah, so we're a few minutes early. So let me go ahead and show you how to write down the domain here. If you want to write a set that only has a few things in it, you put a curly brace, and then you list the things separated by commas, and you don't repeat them. So the domain here is 0, 1, 3, 5. I apologize for going over. I'll make this quick. And the range here is the set 0, -2, 7, pi. I want to emphasize that neither of these are intervals. Right? They're just finite sets. They just have a few things in them. And the way we write those is the curly braces and the things listed inside. All right, is the relation B a function? No, it's not. Why?
Because there's two outputs from the same number.
Good. Which input gets sent to two different outputs? Good. The input 1 gets sent or is paired with two different outputs. Namely, -1 and 7. And that's what's not allowed. All right, what about the last guy?
It's a function.
This is a function. Good. There's no input that gets sent to two different outputs. Here, every input gets sent to the same output. That's okay. And here my domain is the set -2 pi square root of 3, 5. And that's in curly braces, -2 pi square root of 3 and 5. Also not an interval, just a finite set. And the range here, how would I write the range as a set? Very good, just 0, listed once. So when we're writing down sets, we don't repeat elements. The range is the singleton set 0. Okay, guys, that's everything you need to get through the tutorial, the algebra readiness, and the first homework and first quiz, all of which are due next Tuesday at the start of class. So remember, every day at the start of class, you have homework due. You need to work that homework before that class so that you're able to understand what's going on in that class. Think of the homework as practice. Think of the quiz as verification. You have a finite number of attempts on the quiz. I think it is set to just 1 attempt right now. If we end up having trouble with that, I can change it. If you end up stuck on anything, please come to an office hour, talk to me. Don't hesitate to do that. But that is it for now. So please start working on the assignments in My Open Math. If you have trouble with anything, reach out for help. If you have not registered for MOM, please do that right away. And sometime today, I would recommend starting on that homework. That way you're staying on top of stuff and we get off to a good start in the semester. I hope we have a great time this term. Please don't hesitate to communicate. I want to work with you. I want to talk with you. I want to know how you're doing. All that stuff really matters to me. So reach out, whether you're feeling good, feeling bad, just let me know what's going on. That way we can work together and make sure everything goes great. That's it from me. Hope you guys have a lovely rest of your day. And next time we're going to talk about graphs of functions, and we'll see you there. Bye.
Thanks, Professor John.
Of course. Take care, guys.
Thank you.